Let us study the transient analysis of series RC circuit, which we have qualitatively discussed in the previous section. Here you can see in the circuit a capacitor in series with the resistance is connected across a battery of EMF V, and say if we close down the switch at t equal to 0, we know that the battery will supply a current I, and due to this current a charge plus Q and minus Q are deposited on the capacitor. And as the charge on capacitor increases, the current decreases, and finally when the charge on capacitor becomes CV, current in the circuit becomes 0. That already we have studied. Now here we are going to analyze the time variation of current and charge on the capacitor and in the circuit. Say at any time t the charge on capacitor is Q, and say we write KVL equation in this loop at time t. At an intermediate time t, we write down the KVL equation and say we start from this point, and the situation when we move along with the current through the capacitor, as from positive side to the negative side, there is a drop in potential. We can write at minus Q by C, which is the potential drop across the capacitor, and across the resistance there will be a drop, that is minus IR, and then due to the battery there will be a gain in potential plus V, and this should be equal to 0. If we just simplify this expression here, current can be written as we just take this on right hand side, and on simplifying we are getting current is equals to CV minus Q upon RC. And this value of current we can write as dq by dt, because this current is the rate of variation of charge, and this current is only depositing the charge over here. Now in this situation we can further separate the variables like dq upon CV minus Q. This can be written as dt over RC, and if we integrate this expression from t equals to 0 to t, where charge is also varying from Q equals to 0 to Q, then on integrating here left hand side it will become negative of ln of CV minus Q, and we apply limits from 0 to Q, and on right hand side it is simply t by RC, because integration of dt is t, 1 by RC is a constant. So on substituting the limits here we'll get as minus ln of CV minus Q plus ln of CV. So in this situation this can be written as ln of CV minus Q divided by CV is equals to minus T over RC, or this can be simplified further as CV minus Q upon CV is equals to e to power minus T by RC. And this implies if we solve this expression for the charge on capacitor, this charge on capacitor we can write as CV1 minus e to power minus T by RC. This is the charge on capacitor as a function of time we are getting, and we plot the curve of charge on capacitor as a function of time. It comes out to be an exponential curve, and it will look like this. And this curve we can see it is asymptotic for the final charge, which is CV, or we call a steady state charge. So this is the charge as a function of time. Here you can see at t tending to infinity, if you substitute here after a long time infinity, or we write long time after, you can see the value of charge we are getting is CV, that is also termed as steady state charge on capacitor. This is the way how we analyze and solve the charge on capacitor as a function of time.